Hi everyone, welcome to Vishwablooms. So in this video we'll be looking at Bridge Course Maths, which is for class 11th or intermediate, lecture 4. So let's begin. So in this lecture we are looking at exponents and powers and logarithms. So these are the two new topics which are going to see. Exponents and powers is an old topic, but we are going to revise it slightly and we'll focus more on logarithms in this lecture. First, we'll see what is exponents and powers. Let's complete this topic in a very quick time and we will discuss logarithms. So exponents and powers you all know, right, generally. So a number, if it is a power n, it means that a is multiplied n times, right? So you all know this. This is nothing new for you, right? You have been studying since 8th standard, right? So you all know this. Nothing is new. Suppose if I have an example 2 cube, if I write, it means 2 is multiplied 3 times. So this is the base. This is the base, you all know. That is the number to be multiplied, and the power which shows how many times the base has to be multiplied. Am I correct? So whenever you are telling exponent or indices, it means the entire thing, entire exponent. This one, a power n, that is called as the exponent or indices. Okay, whenever you are referring to power or index, then it refers to only the power, that is n, this 2 to n. Okay, and whenever you're talking about the base, it is a. So I hope this is all clear to you, right? Nothing new. Now we shall see laws of exponents, which we have already seen since our childhood, but it's okay. So a power m into a power n is a power m plus n. You know this, right? Now a power m into a power minus n is nothing but a power m minus n. A power n into a power m whole power n is a power mn. A power n whole power m is a power mn. Same thing, no change, right? Now a power m whole power 1 by m, it both will get cancelled, so the leftover thing will be a. Now a power m whole power 1 by n will become a power m by n. You know this. Now a power m into b power m is nothing but ab whole power m. This also you know. Next, a power m by b power m is nothing but a by b whole power m. A power 1, we all know it is just a. Okay, is multiplied one time. Now a power m by a power n is a power m minus n when m is greater than n. Okay, now again, if m is lesser than n, then it is 1 by a power n minus m. Understood? So this is the thing which you should remember. Now a power 0 is 1. Generally since childhood we have been learning anything to the power 0 is 1, except 0 power 0. 0 power 0 is not defined. Okay, again this is very important point to be noted. 0 power 0 is 0, sorry, not defined. But any other number apart from 0 where a is not equal to 0, if you are powering it to 0, it is going to be 1. Now why a power 0 is 1? Let us see. Now a power 0 can be written as a power n minus n, right? N minus n is nothing but 0, so a power 0, indirect. Now 1 I can write it as a power n into a power minus n, right? Because a power n by a power n only it is referring to. Am I correct? Yes. So a power n minus n is a power 0. Now a power n cancel. So a power 0, what is it? 1. So this is how it is actually. Okay, so this is the proof. Okay, just for knowledge, okay, for your information I have done the proof. Next, we have some questions for exponents and powers which we can do. Okay, the first question is actually your part. Okay, you can try out this question, solve it, and just put it in the comment section. This is very easy question. The correct answer will be pinned and it will be liked. Okay, correct answer I will pin it. Okay, so no need to worry. And if you're not able to get the answer, please let me know. I will do this solution in the comment section and let you know the answer. Okay, yeah, let's see the second question. So the question is root 2 by 4. Okay, so first I will write a root 2 as 2 to the power 1 by 2, because a root a is nothing but a power 1 by 2. If cube root of a is there, then it is a to the power 1 by 3. Correct. So in that way I am going to write it in this way. Now 4 I can write it as 2 square, right? Yeah. Now it is in the form of a power m by a power n, where n is greater, right? So m is less than n. So what we can do is 1 by a power n minus m we have to do. Correct. So let's do this. Is equal to 1 by 2 power 2 minus 1 by 2. Correct. So now we will find out the LCM. LCM is going to be 2. So 1 by 2 power 4 by 2 minus 1 by 2. Now 4 minus 1 is 3. So 1 by 2 power 3 by 2, it is nothing but 2 power minus 3 by 2. Now why minus 3 by 2? Because when we have a 1 by a power m, it is nothing but a power minus m. This is the law of exponent, right? So that's what. This is the answer, final answer. Okay. Now let's look at the next question. So this question is 11 by 3 divided by 11 by 3 to the power 7. So here if there is no power, we can take it as 1. So this is also same way we can do actually, a power m by a power n, where m is less than n. So similarly you will do it as 1 by a power n minus m. Am I correct? So same thing we will apply here and try to solve this question. Very simple one. So you will do it as 1 by 11 by 3 whole power 7 minus 1. That is equal to 1 by 11 by 3 to the power 6. Now this one we can write it as 11 by 3 to the power minus 6. Similarly I have shown, right, in that way. Again you can also write this as 3 by 11 to the power 6. See here, when it is minus, you can just flip these things, okay? In the numerator and denominator can be flipped. So this is the answer. I hope it is clear. So with this, the introduction of exponents and powers is completed. So we will have to move on to logarithms. Okay, so logarithms, before moving on to logarithms, for the concept clarity, for understanding logarithms, we will see with an example before starting with the definition and all that. First we'll see example, then we'll understand actually better. Okay, now first exponential form. If I have to write 2 cube, I'll write in this way. Now 2 cube, how will I write 2 cube? 2 into 2 into 2 equal to 8. Or simply I can write it as 2 cube is equal to 8. This is in the exponential form. See, exponents and logarithms are some topics which are related to each other. Okay, so logarithms is just a way to represent the exponents. Okay, so that's what. Now if I have to write 2 cube is equal to 8 in the logarithmic form, what I have to do is I have to write it as log 8 to the base 2 equal to 3. Now you might not understand anything. I know you might not understand anything. It's okay. See, it's very simple. Now I will write it as 8 equal to 2 cube. Okay, this will be convenient for us. Now first just put one log here. Okay, and leave this term here only. Same place. Now here whatever the base is there, no, for this power, Now you have to make that base here under the log, and you should put equal to and write 3 in big font. Okay, so generally this logarithm, actually what we are trying to find is how many times this number is multiplied in order to get this. Okay, how many times this base is multiplied to get the answer. So that is what is logarithm answer. If you want to find out the answer for logarithm, it will denote the number of times the base has been repeated in order to get this logarithm. In understanding, maybe you will not understand, we will do so many examples, okay, so that you will be perfect in logarithms. Fine. Now if I have to give you one more example, okay, let me give one more example. 16 equal to 2 power 4, you all know this. So in the logarithmic form, first just write log and 16, leave it like this. Now the base of this exponent will be the base of the logarithm, now equal to 4. So for getting 16, the base 2 has to be multiplied 4 times. So how many times it has to be multiplied is the answer for logarithms. Understood? So that is only logarithms generally. Clear? So that is very simple, but we will try to understand. We have to understand so many things in detail. So welcoming you all to logarithms. So logarithms and exponents are two similar topics, as I have already told. Now first let's look at the definition. Let n be a positive real number and a also be a positive real number where a cannot be 1. Then x is any real number, and if a power x is equal to n, then log n to the base a is equal to x. Maybe you will not understand anything in the definition. It's just for reading and seeing. I'll tell you, no need to worry. So there is if a power x is equal to n, then logarithm of n to the base a equal to x. That's it. So that is what is the general form. Okay, as now we have seen, right, how to write. So once again I'll show you clearly. See, n is equal to a power x. Now you add one logarithm here, keep that n like that, base a will become here, and answer is x. Okay, so that is the logarithmic form. Now here x is called the logarithm of n to the base a. So how do we read it? Logarithm of n to the base a is x. That's it. Okay, that is how you read it and tell. Okay, so these two are very important, that's why I've highlighted it also. So we'll see a few more examples. If you want, then it will be clear. Again I'll try to take some different example. 4 is equal to 2 square. Okay, this is the exponential form. Now try to write it in the logarithmic form. How I will write? Log you will write first, 4 as it is on the left hand side. Now this base 2 you will write it here in the base place, and answer is 2. Am I correct? Now we'll take one more example. 9 is equal to 3 square. Okay, again how we will write? First write log, then I number as it is, this 3, the base has to be written to the down base, and answer is 2. That's what is examples, right? So now suppose if logarithmic form is given and you are asked to convert it into exponential form. Suppose logarithm of 16 to the base 4 is 2. How we will convert this to exponential form? I will tell you, don't need to worry. First 16 is on the LHS, so keep 16 like this only, equal to, this is the base, right? So now it will be base for exponential form also. So base is bigger, and this answer is power of that base, 4 square. That's it. Understood? Very simple, right? So you should understand majorly. Now one more example shall we take? Okay, so I'll give log 81 to the base 9 is equal to 2. How you will convert this one? First 81 you will write it like that, and the base of this logarithm will be the base of the exponent, right? So 9 you will write in bigger font, and 2 is the answer, so it is the power. It should become small. That's it. Understood? So this is how you write exponential form into logarithmic form and logarithmic form into exponential form. Clear? So I hope it is clear to everyone. So in the definition we have seen one thing. This n is there, no, it should be only positive real number. This a also only positive real number. Am I right? So we should remember those two facts, and a should not be 1. Okay, so one first and foremost thing is that logarithm should be only positive. It is not defined for negative numbers and 0. Okay, it is not defined for negative numbers and 0. The logarithm is only defined for positive number. Understood? Log 0 is also undefined. Okay, log 0 is undefined. So log n to the base a is only defined when n is greater than 0 and a is greater than 0 and a is not equal to 1. When these three conditions are satisfied, then only logarithm will be defined for that particular logarithm. Understood? That is very, very important note point also, and for negative it is not there. Next we have to see something very, very important, properties of logarithms. Okay, these properties are very, very, very important because for solving complex problems these are very essential. Okay, first, logarithm of any number to the same base is 1. That means, suppose for example we have logarithm of 2 to the base 2, because he said logarithm of any number to the same base, same number, same base, then answer simply is 1, because 2 power 1 is only 1, no? See, if you write it in exponential form, it is 2 power 1 is equal to 2. So when you are having same number and same base, simply remember it as 1 is the answer. So log a to the base a is equal to 1. This is one property. Okay. Second property. Logarithm is unique with respect to any base, but logarithm of any number with different bases are different. That means, suppose we have an example, log 16 to the base 2 is 4 and log 16 to the base 4 is how much? 2, right? So logarithm of any number is unique with respect to the bases. Okay, that's what is the point to be noted here. Next we have logarithm of 1 to the base a is 0. Okay, logarithm of 1 to the base a is 0. A can be any number. Okay, a positive real number, because see, now convert this into exponential form. What you will see, a power 0 equal to 1. That's why. Okay, so answer should be 0 only. Log 1 is 0 simply, and log 0 is not defined, remember. Next we have some properties again. Fourth one, see, logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. Now where do we use all this? I'll tell you. Suppose we have logarithm of 12 to the base 3. Now somebody is asking you to simplify this. So you know that, right? Logarithm of 12 is nothing but 3 into 4 mn, and base is 3. So you can simply write it as logarithm of 3 to the base 3 plus logarithm of 4 to the base 3. Suppose if there were other numbers, it would have been easy for calculation, right? So that is where we use such properties. Okay, I am writing the usage. This is usage where you will use. Okay, now next property, logarithm of m by n to the base a is equal to logarithm of m to the base a minus logarithm of n to the base a. Suppose there is something like logarithm of 4 by 5 to the base okay, say 2. Then we can simply write it as logarithm of 4 to the base 2 minus logarithm of 5 to the base 2. Understanding? So you have to, in that cases you should remember this. But remember one thing, logarithm of m plus n is not equal to logarithm of m plus logarithm of n. Suppose you have logarithm of 3 plus 4. It is not equal to logarithm of 3 plus logarithm of 4. Don't try to do this. You will go in a wrong way. Understanding? Similarly for m minus n also same thing. It is not equal. Okay. It is not equal. Should remember these things. Okay. Very important. Next. We have a next property is a to the power log n to the base a is n. Okay, so this is a bit twisting, but it is very easy. Okay, I'll try to explain it with an example so that it will be clear. Okay, now let this 8 should, both things should be same. That's why I represented with the same letter. So I'm taking 8 as 2. Okay, and logarithm of 8 to the base 2. Now simply answer, you have to say it as 8. Okay, but how it works actually, first we will see. 2 to the power, now log 8 to the base 2, it is 4, right? Sorry, 3 is the answer, right? Because 2, how many times when you repeat it you will get 8? 3 times. So 2 cube. Now 2 cube is nothing but 8. Final answer is 8 only, but you have it here only, right? Why do you even need to do this much of calculation? Okay, how it works, I'm telling. So when you have 2 to the power log 8 to the base 2, answer is simply 8. Okay, that's it. Next, so actually before telling the next property, I'll tell you one thing actually. Okay, so log a power x to the base a is actually simply x. So how it actually comes is, see, when you have something to the power, no, it will generally go here. It will become x log a to the base a. Okay, so again log a to the base a will become 1, right? So x into 1 is x. So generally the powers of this number will become the number here. It will go here. Okay, there is a log n property, no need to worry, I'll tell that also. So in that way this will work actually. Suppose you have a logarithm of 2 cube to the base 2, it simply answer is 3, but how it works, it becomes like 3 log 2 to the base 2. So this will become 1. Okay, so 3 into 1 is 3. Okay, see, this is that law. Okay, when you have logarithm of a power m to the base b power n, this numbers power whatever is there, no, it will become in the numerator, and the basis power whatever is there, no, that will be the denominator for that. Okay, so suppose if you have log a to the base b power n, it is nothing but 1 by n log a to the base b. Okay, to the base b. Okay, so these things you should know. I combined that law and wrote in one law, one property only. You can write it as two separate properties. Okay, the previous one whatever I have written, right, two separately you can note. So this one is clear, right, for you? Suppose logarithm of 2 cube to the base 2 to the power 1, you can write it as 3 by, okay, let it be 2, 3 by 2 logarithm of 2 to the base 2, that is nothing but 3 by 2. Understood? This is how it works. Okay, next. So let's look at the next properties also here. So logarithm of a to the base b can be expressed as logarithm of a to the base x divided by logarithm of b to the base x. Okay, this is how, this is also the way when you can, while doing complex problems you can use that. Similarly, logarithm of a to the base b, when you have this form, you can write it as logarithm of a to the base x into logarithm of b to the base x. Okay. Next we have logarithm of a to the base b, which we can write it as 1 by logarithm of b to the base a. So when you want to shift this basis and the number, you can just use this. Okay, while solving problems we will use all of these, so that time it will be very clear for you. So I can't simply explain these ones, right? Next we have 14th one, logarithm of a power m to the base a power n is equal to m by n. So similarly I have shown you just now an example, right? So when you have 2 cube and 2 square as base, it will become 3 by 2 logarithm of 2 to the base 2. So this is nothing but 3 by 2. So simply you can write it as the power side, as m as the numerator, n as the denominator. You can directly write it. It means, okay. Now 15th one, we have a to the power log c to the base b. It is simply, you can write it in this way also, that is c to the power log a to the base b. So these can be shifted, these two can be shifted. So for this also we will do one problem. Based on this also we have one problem, no need to worry. We'll do that and we will try to understand all these properties and problem solving properties and problem solving. Next we are going to see. Okay, in next few minutes you will see that. But before moving on to that, we have two things to know, that is common logarithms and natural logarithms. So common logarithms are nothing but, in this system, the base is always taken as 10. The base is taken as 10. For so in some examples you will not see any base. Suppose log 3 they will give, and they won't give any base, simply they will write it in this way. So in that cases it means that the base is 10. Okay, not 1, it is 10. Suppose if it is logarithm of 4, nothing is given, base is not given, means it is 10 to the base 10. At all common logarithms. Now natural logarithms, in this system the base of the logarithm is taken as e. This is the base of the logarithm. Okay, e is an irrational number, you know, right? And the value is 2.71. It is lying between the values of 2 and 3, right? 2.71 and so on. So those are natural logarithms. So now we will see few problems based on these actually. Okay, so first we have logarithm of 216 to the base 6. So how we will write this as logarithm 216 is 6 cube and base is 6. Okay, so according to the law you will send, so that you all know this law, right? Log a power m to the base a is nothing but a. Answer is finally a, but I'm so sorry, m log a to the base a. Answer is directly m. We know this, right? Law we have seen. So answer is directly 3 we can write, but for steps, for your clarification, as we are new learners, we will do in this way. So we all know that log a to the base a is 1. So 3 into 1 is, answer is 3. So these all you just write it in the bracket whatever we have used. Okay, I will be erasing it because I need some space. Fine. Next question, we have second one, that is logarithm 1000. So log 1000, that's it I have given, but what is the base you would be thinking? So I just now told, right, common logarithms and natural logarithms. So when there is no base, just write 10. So logarithm of 1000 can be written as 10 cube, am I right? And 10 is 10. Same thing, using this law, log a power m to the base a is equal to m, just write it as 3. So 3 is the final answer. Next we have one more question, that is logarithm of 81 to the base 1 by 3. So this one how can be solved? Logarithm 81 can be written as 3 power 4. So how do we find all this? Is by doing the prime factorization. Now 1 by 3, it is in the form of a power 1 by a, so it is like 1 by a, right? So 1 by a can be a to the power minus m. Am I correct? So in that way only I will write 3 to the power minus 1. Now this is like logarithm of a power m to the base a power n. Answer is m by n. We know, right? So it is going to be 4 by minus 1 logarithm 3 to the base 3. So logarithm of a to the base a is simply 1. So answer is minus 4. Okay, minus 4. So this loss I am erasing. So first, while solving the problems for the first time, try to mention all the properties used, then only you can remember them very easily. Okay, for the first time if you're doing, better to mention. Okay, now next question is logarithm of 27 by 8 to the base 3 by 2. So logarithm of 27 by 8 can be written as 3 by 2 whole cube. Am I correct? To the base 3 by 2. Similarly, using the same log n, it is nothing but 3 log 3 by 2 to the base 3 by 2. That is answer 3. That's it. Right? So these are actually easy questions on logarithms. So if you want more complex problems on logarithms, they are actually already available on our channel and techno videos. I will place the playlist link in the description. Okay, don't need to worry. Playlist link I will provide it in the description box. Do check that playlist. In that you will find n number of complex problems in each video. The complexity will increase like anything. So you can actually enjoy solving those problems. So yeah. So thanks for watching our video. Do like, share and subscribe to Vishwablooms. Bye bye. See you in the next lecture.